Hi, it's Teacher RJ, and this is our P5 science class. Welcome on our first online learning. Has has anyone ever eaten ice cream on a hot summer day? What happens to ice cream if you don't eat it fast enough? That's right, ice cream will melt. Have you ever left a glass of ice or water out on the table? What happened to the ice after some time? That's correct. The ice will melt and turn into water. Today's lesson, we are going to explore the causes and the reason why ice will melt if you pull it out of the fridge. And if ice melt, do they always melt at the same speed? What factors affect how fast ice melts? So at the end of this lesson, everyone is expected to first list examples of water in each of its three states. Very easy. Second, each and every one of you should be able to state the freezing point and melting point of ice. And lastly, but not least, recognize that a change in state can occur when water gains or loses heat. In P4, you've learned about matter and its properties. To quickly revise that lesson, you've learned that matter is anything that has mass and occupies space. There are three states of matter, namely solids, liquids, and gases. Solids have definite shape and volume, just like coin, a paper, a cell phone, a computer, a laptop, a plate, or even a table. They can stand on their own and they have their own shape. They also occupy a fixed amount of space. Now, liquids are different from solids. Though they have a definite volume, that means they occupy fixed amount of space as well, just like solids, they don't have their own shape. That means they cannot stand on their own, and their shape depends on their container. If you place liquids in a star-shaped container, then their shape will probably be a star. If you place them in a circular container, then their shape is absolutely circular, just like its container. Gases are very unique and very different from both of solids and liquids because aside from they don't have their own shape, they also don't have definite volume. So though they occupy space, the space or the amount of space they occupy is not fixed. And that's why among the three states that matter, it's a type of matter or a state of matter that you can easily compress. So if you remember your experimentation using a syringe, when you push that syringe more, the volume of the gas inside the syringe will decrease. Because again, gases do not occupy a fixed amount of volume or space. Now, among these three, or among these examples of matter, water is very different. Is that because it can exist in three different states? It can exist in solid, liquid, and gas. And aside from that, it can actually change state depending on the amount of heat they lose or they gain from their surroundings. A solid, for example, can turn or change state. It's liquid. And liquid can change state into gas in the form of water vapor. And vice versa, this water vapor can also change back to liquid in the form of rain. And this water can also turn back to ice. Now, when solid state changes into liquid state, we call that process melting. Solid contains the least amount of heat. Its molecules are almost not moving because they're very closely packed together. Now, why do solid or ice melt? It's not magic, actually. Solid or ice melt when they actually gain heat. It's about the transfer of heat. You also learn in P4 that heat travels from a warmer area to cooler area. And since ice contains least heat, and if you put an ice outside of the fridge where its surrounding temperature is higher than the ice, then the heat from its surroundings could actually transfer to the ice, and the ice will gain heat. The ice will take this heat from its surrounding air, from the surrounding container, and if you place it in a plastic or a table or metal, then it will also gain the heat from there. When that happens, the ice will expand and melt. And as they melt, they turn their state into liquid. Liquid then contains more heat compared to the ice. So it's very easy. Again, melting is a process where an ice changes from solid state to liquid state when ice gains heat from their surroundings, expand, and melt. That is melting. So from the start of our lesson, I asked you what would happen to ice cream if you don't eat it long enough. And we learned and we observed most of the time, it will eventually melt, it will slowly melt. The reason of that is because of the heat. When the surrounding air is warmer than the ice cream will gain heat from the surrounding air. And again, when that happens, the ice cream will expand and melt. So that is about the melting process. I hope that's very clear. Now, freezing. Freezing is a process where water changes from liquid state to solid state. So this is the vice versa. This is the opposite process. When water changes into ice, that is what we call freezing. Now, how does that happen? What could trigger or cause a water state to change into solid state? We learned earlier that water contains more heat than the ice. So when you place a water in the fridge, these water molecules will actually lose heat. It will gradually lose heat to its surrounding air because the surrounding air is cooler than the water. When that happens, the water molecules will slow down, come together, and form into solid state, and they become an ice. So that is a freezing process. Let me repeat. Freezing is when water loses heat, come together, and form a solid state or an ice. Remember that a water contains more heat and then ice. So ice cubes form in the fridge because it loses heat to its surroundings. So it's not actually magic. Okay, that's how ice or ice cubes form in the fridge. The fridge will provide an environment with a lower temperature than the water and then causes the water to freeze into an ice. What is the freezing point and melting point of water? Now, pure water freezes and melts at 0 degrees Celsius. I think you know all of that. You know that already since P3, I suppose, or P4, because you learned that. Pure water, without the presence of impurities, without the presence of other substances, they actually freeze at 0 degrees Celsius. At the same time, pure water or ice from pure water can melt at 0 degrees Celsius. So the freezing point and melting point of pure water is the same. That is 0 degrees Celsius. Ice melts at 0 degrees Celsius. Water freezes at 0 degrees Celsius all the time. Now this graph in here shows a relationship between the temperature and the heat. As I have mentioned a while ago, melting and freezing is about gaining and losing heat. So the heat and the temperature have directly proportional relationship. When the amount of heat increases, the temperature increases. And as that happens, the state of matter also changes. Now you can see in here 0 degrees Celsius to 100 degrees Celsius. Now this part here, we're going to learn it on the next lesson, the next video, okay, the next coming week. Now today, let's focus on the freezing point and the melting point, which is 0 degrees Celsius. Now, as you can see in here, the solid can actually stay solid from 0 down, all right? Because the absolute 0 degrees Celsius is lower than 0 degrees Celsius, all right? So 0 degrees Celsius is the breaking point where ice melts and water freezes. Temperature above 0 degrees Celsius, that is when an ice melts from 0 and above. And liquid actually freezes from 0 below. Okay, so the freezing point is the breaking point. Actually, freezing process and melting process can coexist. If you provide an environment of pure water with a constant amount of heat, constant, that means it's not changing, it's not increasing, it's not decreasing, melting and freezing can coexist. Solid ice will melt, and those melted part of the ice at a given temperature or environment will eventually freezes. It goes back and forth. It freezes, it melts, it freezes, it melts. It can coexist. Again, provided that the amount of heat is constant, not changing. All right? If you put them in the fridge and set the fridge or the temperature of the fridge into 0 degrees Celsius, then that happens. Because again, the freezing point and the melting point of ice is the same. Okay, they are the same, so they can coexist all the time. Now, both of these water freezes at 0 degrees Celsius. If you have a pail of water and a glass of water, they both freeze at 0 degrees Celsius. Again, without impurities in it, without other substances in it. However, they might not freeze at the same time. Why is that? A pail of water contains more water. That means it has more molecules. More water molecules means more heat. So it would take time for them to lose all of those heat and reach 0 degrees Celsius. And therefore, a pail of water will freeze slower than a glass of water. Is that clear? A glass of water contains less water. That means it contains less water molecules and therefore less heat. They freeze as faster because they can lose this heat faster. And to get into 0 degrees Celsius is really fast compared to a pail of water. Let me repeat. A pail of water and a glass of water will freeze at 0 degrees Celsius, which is the freezing point of a pure water. However, because of the different amounts of water, the different volumes of water, they will actually reach 0 degrees Celsius at different amount of time. With more water, they have a lot of heat to lose to reach 0 degrees Celsius. With less water, they have less heat to lose and reach 0 degrees Celsius. And therefore, less water freezes faster than more water. Different objects have different melting points. Gold, for example, melts at around 1064 degrees Celsius. That's very hot. Tungsten, on the other hand, melts or has the highest melting point among all the metals. And that's the reason why we use them in incandescent lamp or bulb. Because even at a very thin, even if they're very thin and they become very, very hot, they burn out and produce a lot of heat energy. They don't easily melt at that temperature because their melting point is around 3,422 degrees Celsius. Gallium, on the other hand, melts at 29.76 degrees Celsius. And therefore, if you place them on your palm, which is around 37 degrees Celsius, they actually melt. So this is an example of a melting point. Melting points are the points where solids start to melt. Next one, different objects have different freezing points. If they have different melting points, different liquids also have different freezing points. Example is an alcohol. Alcohol, which we use it to wash our hands or to clean or disinfect wounds, actually freezes at negative 114 degrees Celsius. That's very low. And ice cream freezes at negative 3 degrees Celsius. So if you keep them in 0 degrees Celsius, ice will actually melt because they have to be at around a negative 3 or below degrees Celsius to maintain their solid state. Above negative 3 will make them or cause them to melt. Blood is about negative 2 or to -3 degrees Celsius. Not the blood in our body though, because our body will provide heat for the blood. So even if we are in an environment below -2 or -3, our blood will be protected and it won't get that amount of temperature. But if you take that blood away or out of your body, it places it in an environment with -2 or -3 degrees Celsius, and that's when our blood actually freezes. Interesting facts, right? Now, do ice always melt at the same speed? Now, let's go back to talking about pure water. Do they always melt at the same speed? What factors or factor affect how fast ice melt? Now, this experiment here shows how ice or impurities in water could affect the freezing point or melting point of the ice. Okay, so let's watch it. That is actually a digital temperature sensor. So that's reading. Now notice that Aisha is now adding salt onto the water bath. There we go. As Shiv said, during the beginning of the test, the temperature immediately dropped. Okay, immediately dropped into 0 degrees Celsius. It stays here until okay, let me bring you back to that reading. So when she added salt, or at the beginning of the experiment, when she added salt, the temperature of the water actually immediately dropped into below 0. And then it stays at 0 degrees Celsius as the water changes state from liquid to solid. And that is what we call the freezing. So the freezing process stays there until all the water or the water freezes, changes state. As that continues on, as all the water molecules freezes, they now go and down below 0 degrees Celsius. And that means with the addition of the salt in the water, the freezing point and the melting point went down. It decreases. Instead of just 0 degrees Celsius, it went lower than that. Salt or impurities in water decreases its freezing at melting point. And that means if pure water freezes or melts at 0 degrees Celsius, when you add salt in it, it freezes or melts at temperature much lower than 0 degrees Celsius. In places where that experiences winter, one of their major problems are the roads. One is because it's very dangerous to drive in an icy road because ice will make the roads very slippery. So what they do is they apply salt, all right? Salt mixture or water with salt in it and then damp it on the road to prevent the ice from freezing. Isn't that awesome? Now the question is, how does that work? Now it works because, again, as I have mentioned, as you add salt in the ice, their freezing point actually decreases. So let's say it decreases to -3 degrees Celsius. So if the surrounding environment is only 0 degrees Celsius and ice forms at 0 degrees Celsius, as we all know, then if their freezing point goes down to -3, then that means the ice or the water will no longer freeze at 0 degrees Celsius. It will now need a -3 temperature before the ice forms. And that's how it works. Now, if the roads are covered with salt, it needs lower than 0 degrees Celsius before the water or the ice forms on the road. And that's why, as you observed here, all the sides of the roads are or has a lot of ice in it, but the road remained free from the ice. It also happened when in around ice cream tube. If you have experienced and noticed this one, when you have ice cream there and you bring the ice cream tube outside of the fridge or in a cooler environment, what we do is actually pour a lot of ice around it and place ice on it or salt in it. When you place salt or add salt on the ice, the temperature that these ice is providing to the ice cream tube is actually lower than 0 degrees Celsius because, again, it decreases the freezing point and melting point of the ice. So since ice cream needs or freezes at -3, when you place salt into the ice and its freezing point decreases, it becomes very cold and it actually provides a cooler, much cooler environment to the ice cream tube, which keeps the ice cream inside the ice cream tube to be in its state, the solid state. All right, so I hope we learned something today. Now, just a recap of what we have learned. First, we learned that water can exist in solid, liquid, or gas. We also learned that change of states occur when water gains or loses heat. Water freezes when it loses heat, and that is freezing. At the same time, ice melts when it gains heat. That process is called the melting point. 0 degrees Celsius is the pure water's freezing and melting point. That means they freeze and they melt at 0 degrees Celsius all the time. And lastly, salt decreases the freezing and melting point of the ice. So that's all today, and I will see you during the activity. Thank you for listening, and